stop repeating the same result and cover more intents with xQuAD. This is the setup you'll be able to run after this, which diversifies candidates to cover likely intents and balances relevance for a better top K. I'm Professor Pi, teaching search and IR with simple Python. Search results can be boring when they all answer the same intent. Real queries are often ambiguous. A user might mean one of several things, and serving only the top relevance item wastes chances to satisfy other intents. Intent-aware diversification tackles that by balancing relevance with coverage across possible user intents. People use it in web search, product search, and FAQ systems to improve user satisfaction without dropping overall usefulness. Intuitively, xQuAD works like a smart picker. Start with a relevance-ranked list. Then, at each step, ask which candidate both scores well and brings something new. You weight relevance against novelty. The result is a compact list that covers different interpretations of the query. We will build a tiny demo. It uses short documents about programming topics and a single ambiguous query. I will show a baseline relevance rank, define a few likely intents, compute simple coverage, and then run a greedy xQuAD selection to produce a diversified top 3. No heavy libraries, just clear logic so you can map this to larger systems. First, we will build a simple baseline to see what relevance-only ranking returns. This snippet builds a tiny retrieval baseline that scores documents by a simple term overlap score, normalized by document length. The variable docs holds short, interpretable texts for the ambiguous query, and Q contains the query terms. The function score computes how many query words appear in a document divided by a length penalty to yield fractional scores. The list rank is produced by sorting documents in descending order of this relevance score. This simple baseline establishes the candidate set and a deterministic first-ranked document we will reuse. The printed top document and its score show which item dominates under relevance-only ranking, motivating diversification. Next, we will define a small set of likely intents and a way to measure document coverage for each intent. This example sets up likely intents and measures how well each document covers them. The dictionary intents maps an intent to its representative terms, and pry encodes intent priors, p-intent, query that xQuAD will use. The function cov returns a simple coverage proxy p-doc-intent as the fraction of intent terms present in a document. The expression best searches across all document intent pairs to find the highest coverage case, offering a quick sense of which intent is easiest to satisfy. Increasing the size of an intent set makes cov stricter. Decreasing it makes coverage easier to achieve. The printed pair highlights the strongest single intent match among candidates, clarifying the landscape xQuAD must balance. Now, we will implement the xQuAD scoring formula for a single selection step and pick the next item after the top baseline. This code performs a single xQuAD selection step to pick the next result after the relevance first choice. The function xScore blends the baseline relevance from score with an intent diversity bonus that increases when a candidate covers intents not yet satisfied by the set S. The term S is initialized with the top baseline document rank 0, and lam controls the trade-off between relevance and diversity. We then choose the candidate that maximizes xScore, resulting in a diversified second pick. Larger lam emphasizes novelty toward uncovered intents. Smaller lam stays closer to the relevance baseline. The printed identifier and score show which candidate wins given the current S and lambda. Next, we will add a near duplicate document and compare how different lambda values change the selection. This snippet adds a relevant strong near duplicate D5 for the language intent and compares xQuAD's next pick under 2 lambdas. The helper pick with creates a temporary selected set containing the baseline top result and finds the best next candidate by calling xScore with the given lamb. With lamb at 0.1, the model favors relevance and selects the near duplicate, reflecting minimal diversity pressure. With lamb at 0.9, diversity dominates, and the selection shifts toward an alternative intent rather than another language tutorial variant. Increasing lambda generally penalizes candidates that cover already satisfied intents, while decreasing it tolerates redundancy. The printed pair makes the trade-off visible in the document identifiers. Finally, we will run a greedy loop to build a small diversified list and report simple coverage and relevance metrics. This snippet completes a minimal greedy xQuAD ranker and summarizes its outcome. The function select builds the final list S by repeatedly choosing the candidate that maximizes xScore given the already selected items. After producing the top 3, CR counts how many intents receive any coverage and normalizes by the number of intents to yield a coverage ratio. The variable MR averages the baseline relevance scores over S to track how much utility we retain. Raising K typically increases coverage, but can dilute average relevance depending on lambda. The printed metrics show a balanced outcome where multiple intents appear while relevance remains strong, delivering a compact, diversified baseline. In a real system, this toy maps directly to a candidate generation stage, followed by re-ranking. The small doc set becomes candidate pool. Coverage becomes a cheap signal like term fractions. And xQuAD is the re-ranker that trades off relevance and novelty. Recap. xQuAD is a greedy re-ranking method that mixes relevance and intent coverage. Use it when queries are ambiguous and you want a compact top K that serves multiple user intents. Caveat: it depends on reasonable intent priors and coverage signals, so poor priors can hurt rather than help. Next step: tune lambda to match your product goals and measure how coverage and average relevance shift as you change it. If short, practical IR helps, subscribe and watch the IR videos.